right? So we have this issue that like we want our GitHub Actions to be able to connect to AWS. And that's for Terraform, right? When we do like Terraform init and then Terraform apply. And to set that up, there's like two different components. One is basically like the login, right? And that's, by the way, that's just in general. That's authentication. We've all heard that word, right? But the reason why I bring it up is that's different from authorization. Okay? So the authentication part, and this is like good to know just for any kind of web service or anything to know the difference, right? Authentication is like, who are you? You know, like you registering or you logging in to specify I am this person. Okay, so this is like identifying who is the user. Okay, and then authorization is like, okay, given that we know who you are, right? Given that you are this person, what are you allowed to do? All right, so those are two different components. So the identity provider part, that's all about logging in and authentication. Like, we're kind of creating a portal, or like you can really just think of like a login page, so that GitHub Actions can say like, this is who I am, right? I'm logging in, and then the next thing is we create a role saying like, given that I'm this person, I get to assume this role, and with this role, I get these permissions. All right, and then we were just giving it like, admin permissions for it to kind of like interact with any services, but in real life, you'd probably restrict it more to just the services that are needed, and you can always update it from there. So, okay, so we can start to look at kind of how we do this, right? We have this push event, on push to the main branch. We will, this is the GitHub Actions environment, right, that we'll be using, so it's in Ubuntu. And then this is using, right, these predefined actions, right, like, remember what checkout does, right, that's just like downloads your current repository. This is another predefined action for logging in to AWS. And remember, kind of like the way that we do this is, one, we set this IAM role, which corresponds to the ARN of the role, right? This role that you create. You just plug this into your secrets. So that's kind of one side, right? You have to know this ARN role for someone to log in. And the other side is, I don't think I can, it might take a second. In AWS, when creating the role, we said, we remember we did that web identity federated user thing, and yeah, it's going to take an auth code. Well, we did that web identity federated user, and then we said that we specified both the organization in GitHub and also the repository, okay? So when you make a request, like when GitHub Actions makes a request to the secure token service, and tries to assume the role will check to make sure that the request comes from the correct repository. All right, and if it doesn't, you'll get an error. Then the next thing is, right, logging into ECR. So this is kind of like what we covered last time. Any questions about that, like those steps? Right? The main place that you'll get held up is if probably like you when creating the role, you do not properly set the configuration about like your GitHub account, like your the GitHub username and the GitHub repository, like that kind of thing. All right, so then the next thing is basically we want to be able to push, create a Docker image from our code, right? So you can see we have this just simple Flask app and a Docker file. So whenever you like make a change to be like hello world everyone, think about what has to happen. We have to rebuild this image, and the Docker file, that will actually take care of it because it just takes the code from the working directory and copies our source code, builds in it, installs our requirements, etc. And then when we run it, it will run Flask. So every time we make a change to our application, we basically want to rebuild the image, and then we want to push it up, right, to my ECR. And because my GitHub Actions environment is logged in, we should be good. So, okay, so what do we do here? This gets the registry, and it gets it from this step, this previous step. So when you log into AWS, each account only has one registry. It's basically like your account number and then your region. Remember this, right? And so this is actually, it's able to figure out what this, like what essentially your ECR repository is. You only have one per an account. So it basically says from this step of login ECR, I'm going to get an output, and it's going to spit out to me what the registry is. So you can think of this outputs as like being a dictionary or an object, and I'm doing like outputs.registry, which is, you know, coming from this step. And then this ECR repository, this you have to specify, right? And I think in this case, like in the lab example, we're saying like, hey, you should have this already up there, like already created, and then we're just tagging, you know, the latest image. So then this working directory is important, right? Because remember, you're cloning down everything. So the working directory is saying like, you should be in this directory when you do this. And why is that important? While you're doing Docker build, you need to be in the folder that has the Docker file. Okay, so we're Docker build is going to look for this Docker file and then set the right tag, so then eventually we can push up to that same registry. So Docker build, use the ECR registry and the ECR repository and the image tag. All these are environmental variables, right, which we set here. Okay, so here we're just setting environmental variables for this step, right, and build the current context. And then so once we build it, then we push, okay, and include like the latest. So that's just the image tag. Then we need to, like, you can imagine what this does, right? This is a pre-defined step that just installs Terraform. I guess here we specify the version, and then we call it Terraform init, Terraform plan. We don't really need to call it Terraform plan, but it's like, I guess it's like a way of like verifying and probably potentially can make it a little easier to debug or at least log some information. And then we do the Terraform apply. The auto improve is because remember you always have to type in yes. And then I added this step of like, if there's a failure, call destroy. This way, because for me, every time I was trying this out and it was failing, you can't. One thing to note is when you call Terraform apply, you're doing it on your GitHub Actions environment. And the only way to destroy is if you have access to the state file, right? So if you try to do like Terraform destroy, it's going to look for your state file to see like what AWS resources to destroy. So you can only do that you can only call destroy from your GitHub Actions computer, because that's what has the state file. So anyway, I was adding this line that like, if I mess something up, please from the GitHub Actions environment, call destroy, right? That way I don't have these lingering EC2 instances and policies or whatever. So that's what's going on here. This ID token of write, this is because AWS sends the GitHub Action environment a secure token, right? That basically is its login, and almost like a cookie, right? So that it can like log in and interact with AWS. And this is allowing us to write this token and save the token that comes from AWS. All right, so once you call Terraform apply, right? So we've already built our image, we've already pushed it up, then we call like Terraform apply, we say yes, and then we go to this part, right? So we set the region, or at least I did, the key name, right? This is our PEM file, we know that. And then this is when you call Terraform apply and our EC2 instance gets booted up, this is what's happening next, right? Because this is in user data. So just remember from previous lessons, we could put this in a like template file, right? And just have it declare like a template file and put that over here. Remember all that? And then it will just like call .rendered, I think it was, on the template file. And then maybe that's probably a little bit better, but this is fine. So what are we doing here? We're getting the okay. So we're basically able to like I don't like hard coded. I could have hard coded in where my ECR. This is my ECR repository, right? And it always follows a pattern. This pattern, like your account ID, the region.aws.com. I don't like hard coding that into my, into my code because then it's like not secure. Uh, so what we're doing is we're getting that account ID just dynamically. And the way I can do that is by doing the AWS Secure Token Service get the caller identity. Remember that gives you back we've seen this before, that gives you back a dictionary of your account ID and also like the role. And here I'm doing get, of the dictionary that I get back, basically get that account. And the account is the account ID. So here I'm just using the command line, the CLI, to get the account number, and then setting it equal to this, setting my AWS account ID equal to that output. Specifying the region, right? You could imagine like refactoring this and putting these all in local in variables, and that probably would be a little better. The Flask, the backend container for later on, and the repository name. Then I install Docker, start it, and then it's like the same step we saw before, right? We have to log in to Docker, or get the login password from ECR. That gives me my token to ECR, and then from there I need to use that token to log in my Docker client. Passes in the password. I think that's basically it. Then pull this down, pull down this specific image, and then here, right, I'm using my little check, make sure while the Docker container is not running, look for it, see if it's there. If it's not there, then run it, map the ports. I guess I'm running it in the background for some reason, and specify the platform to be the one that matches on AWS's computer. And this is I'm running this specific repository, this image. Right, and just retry if it fails. And then remember we have to set up the security group. What is this for? This is to say so I can this is for SSHing in right on port 22. This is for exposing the right port 80, so that you can actually make a request to the website. And then we also have our policies, which we saw before. So we associate, I'm guessing, this is my EC2 profile, which probably this eventually points to. Yeah, so here's my profile that points to the role, and then I have to set both the assume role policy for this role. So it says an EC2 machine can assume the role, and then we also have to say what can it do, and it can read from ECR, EC2 container registry read only. So with that, basically the key thing is that it can do this step, right? It can get the login password, which is really just a token, and then pass that, pass that password, and log in to my ECR, right? So this is just like my account ECR. And then once it's logged in, then it can pull down the image. So that's really what the policy is about, is setting up a policy so that we get access to ECR. And I don't know if we're ever doing anything here. I guess we are. And then here's my security groups, right? Setting when a request comes to port 80, send it to port 80, let anyone make the request, and then also let anyone access via SSH on port 22. And we already had that PEM file set as example for me. Okay? That's the whole shebang, I believe. The one thing, right, that me and Conwell were trying to figure this out, we were not successful. At least I wasn't. The one kind of next part is we do have this issue where, and I think I put this in the reading, that you're not really able to reapply this thing. Why? Because the state file is stuck in your GitHub, right? The Terraform state file that's created is going to be stuck in your GitHub Actions environment. So what you're supposed to do is from GitHub Actions, save that file in an S3 bucket, right? So write it to an S3 bucket, and then from there, the next every time you build a you build this GitHub Actions, you can specify, hey, use that state file. What will that do? It means that like if you reapply, you run your GitHub Actions again, instead of every time it runs creating another EC2 machine like from scratch, it will look at your state file to see do we already have an EC2 machine, right? And if you do, then it's not going to build you a new one because you don't need it. Same thing, of course, like if later you want to destroy, right? Call Terraform destroy. You need the state file, right? That's where how it knows all those resources associated with this Terraform configuration. Cool. So that's the next step. I decided to stop there, but like you can look at the blog, and then I'm sure there are some other ways we could probably, like that blog, we weren't able to get it working that way, but there's probably some other ways. There is a command line interface, like the same way that you can do AWS STS. There's like AWS S3 to like, and then I forget if it's like push or something like that, but you can use the AWS CLI to then push a file up to a bucket. So that's what I'm imagining. Like if I was to really spend hours on this, that might be the path that we eventually went down, is like use the CLI to push the state file up, and then use this AWS command to pull down the state file. All right. Cool. Question, like I said, there's a reason why we went through this. A lot of reasons, but like one is it's a very good thing to have because, like I said, this is a very nice to have thing for a lot of companies, for a lot of like open source repos. This would be really nice for them, and they probably don't have people that know it. And so like, yeah, if you can demonstrate this, really good. And then the other thing is, of course, a lot of companies do use it, like just if they have a serious data engineering team or a DevOps team. So like just the fact that you can integrate with that workflow is great. One other thing somebody mentioned was like, I think this was Param, who was kind of like asking, well, like, what if like accidentally you just delete the you can imagine like just deleting something from here and like pushing it up, and then all of a sudden your GitHub Actions run, and like somehow I just wiped out the database because I changed like 3 lines of code. What you could imagine happening maybe to avoid that is, one, right, like maybe we change the permission, so that's not exactly possible. And then 2, maybe you have I don't know, like I'd have to research this further to see what people do, but you could also imagine like having this repo, that like this Terraform, in a separate repository for production, right? So that if you want to change the production infrastructure, maybe that's not part of the normal dev workflow, but like the DevOps team has that or whatever. You could imagine that, like, right? Because if you mess it up, it can impact a lot. So I would, walk through this yourself, maybe spend some time starting with the GitHub Actions and like see if you can explain this to yourself. Cool. Right. Oh, so Scobie said that's kind of what, one of his teams did, was have Terraform in its own repo. So it seems like that is a, practice that some teams will implement. All right. So that's that.